is Thomas Christopher, and my job title is geochemist, petrologist at the observatory here in Montserrat. If I could give you a good analogy, it would be like going 3 or 4 rounds with a heavyweight boxer. That's the St Vincent, the Vincentian volcano, versus going 15 to 20 rounds with a lightweight boxer, which is our volcano, because the explosions are much bigger. Everything is bigger. It's very intimidating when it's erupting. It's loud, it's angry, but it's short-lived. Whereas ours, it doesn't get as big, but it just wouldn't stop. So yeah, they come at you differently. You know, so I think the main difference is just that one was really intense and violent. The explosions didn't even last a month. They started on the 9th, and by the 23rd, they were over. So most of the eruption involved just the pushing out of this material that built the dome for what, 4 months? Maybe 3-4 months. Then after that, it exploded for 3 weeks, and that was it. So maybe once again, if that old material was not there, maybe this eruption would have been done and dusted by the end of January. Even that it started late December, it would have probably, worked itself out by the end of January. So, I mean, things could have gone very different in terms of how it unfolded. And these are lessons that we definitely need to learn, especially for people who work on that volcano, because, you know, when you sit and really think about what we were doing, you know, that dome could have exploded anytime we were up there. You know, it would have been a very different story. So that's one of the things that we need to definitely try and get a handle on is how explosive domes from this volcano can be, especially if you're going to be monitoring that volcano. And you know, when you're there, helicopters are rare, so everything has to be done on foot. And it's about a 3-hour climb to the summit one way. And it's not some place you can get out of easy. So if you're up there and there's a problem, then, you know, it's luck, I guess, if you survive it or not. So it's a very different situation. So we have to be that much more careful. You know, it's not like here where we can escape quickly if we need to. It's very different.
My name is Dr. Adam Stinton. I'm a volcanologist, and I have responsibility for dome volume and deposit mapping of the eruptive products from the activity here. Well, the key differences are its size and its shape. The one in St Vincent has a very large crater at the summit. It's over 1 kilometre in diameter. Also, the eruptions in St Vincent tend to be a lot more explosive, from what we can tell, certainly compared to what I've seen here in Montserrat. So those are the two key sort of differences I take away from between here and St Vincent.
My name is Roderick Stewart, and I'm the volcano seismologist at Montserrat Volcano Observatory. It's a normal volcano. It seems to be a volcano that has a short eruption. So we had the eruption started and then it carried on for days and that, but it now seems to have been quiet since. And that's what most of the volcanoes in the Caribbean do. Montserrat's totally different. It's now over 25 years since it started erupting, and although it's been quiet for quite a long while, it is a very drawn-out eruption. So they seem to be very different styles of eruption.
My name is Karen Pascal, Dr. Karen Pascal, and I'm the volcanologist specializing in volcano deformation. Yeah, I think for me it really gave me some experience on what kind of signal I could expect when the volcano is actually when the magma is actually going towards the surface. But before I had more experience about that, but more theoretically. I think that's a big thing that St Vincent brought to me, is the practical experience, and as well, obviously the emergency, having to work all the time basically to try to get the data and give some information as fast as possible to the emergency management team. in the field.
Victoria Miller, and I'm the Hazard and Risk Specialist at MVO. The main ones are the composition of the magmas at each volcano are different. So La Soufriere is dominated by basaltic andesites, whilst Soufriere Hills volcano here is dominantly andesitic. And so La Soufriere erupts on a semi-regular basis, let's say. So we have a fairly good record of the timing and the nature of previous historic and prehistoric eruptions. Whereas the Soufriere Hills, it erupts less regularly. So the previous historic and prehistoric eruptions are not so well documented. And that comes into play for the sort of work that I do in the hazard and risk assessment. La Soufriere tends to produce highly explosive but short-lived eruptions lasting more like days to months, that kind of context. Whereas the Soufriere Hills, as we've seen, is capable of producing eruptions that can last for several years. So I think that's a really key difference.